Perfect problem 3 solutions. Essentially, what you're trying to do is figure out the xy coordinates for these points E, F, and G here. Which, if you have your unit circle memorized, you might already know that they are root 3 over 2 and 1/2, root 2 over 2, and root 2 over 2, and 1/2, root 3 over 2, respectively. But a way you could come up with those if you didn't already know those is by kind of following through these steps. So let's see, for G, first I'm going to try to figure out this point right here. First, create another point G prime on the unit circle that has the same x coordinate as G. Okay, so the x coordinate, the left and right is the exact same. I must be talking about this point down here. So I'm going to call this guy G prime. And then it says, note that triangle GAG prime is equilateral. So if I created this triangle right here, that's not bad, that all three of these lengths are the exact same. And the reason you know that is because this is a 60-degree angle, and these angles are the same, and the sum of the interior angles on a triangle is 180 degrees. So these must be 60 degrees also. And if they're all 60, if the angles are all the same, the sides must all be the same. Anyways, length AG is 1 because it's a radius on the unit circle. All right, the distance to any point out here on the circle must be 1 because it's a unit circle. So if this distance is 1, then G prime is also 1. And that's because this is an equilateral triangle. And so then the distance from G to D is 1/2. You can kind of use symmetry there, right? If this whole length is 1, half of it is a half. Half of G prime. Fine. So we know that this length is 1/2 right here, and this length is 1. And so we can find AD. One way to do it would be using Pythagorean Theorem. A squared plus B squared equals C squared. So 1/2 squared plus the thing I'm trying to find. I guess I don't need parentheses there. I'll call it X. So 1/2 squared plus X squared is equal to 1 squared. And so if you solve for X, you'll get that X is equal to plus or minus the square root of 3/4, aka the square root of 3 over 2. And it's got to be positive because my X coordinate here is positive. So GD is 1/2. That tells me that this is 1/2. And then AD is root 3 over 2, which is that value. So I guess this is all for part A. Part B. So for part C, says to find the coordinates of F here, use the fact that F is halfway between this point and this point. So this length AC must be the same as this length CF. So really what we're getting at here is we have this triangle, kind of a poorly drawn triangle, where this length is the exact same as this length, and this length is 1. Maybe if I label the points, it'll be a little bit more clear. This is A, and this is F, and this is D. Nope, C in my picture. And this length is the exact same as this length, and I know this length is 1, again, because it's the radius of the unit circle. So I know that x squared plus x squared has got to be equal to 1 squared. In other words, 2x squared is equal to 1. So x squared equals 1/2. So x is equal to plus or minus the square root of 1/2, plus, because I'm talking about lengths here. And if you rationalize that, you get root 2 over 2. So this length right here is root 2 over 2, and this length right here is root 2 over 2. Those are those values right there. And then for part C, really it's the same as part A, but fine, I'll do it again. For C, what you're doing is you're creating another point over here, and I'm guessing we're calling it E prime. What that does is it gives us this equilateral triangle. Yeah, good enough. And it's really the same logic up here, that the distance from A to E is 1, because it's a radius of the unit circle. And so the distance from E to E prime is also 1. And same thing because it's equilateral. And so if I create some point right here, and what's my next letter? E, F, G. Is there an H? Do I see an H? H anywhere? Nope. Call this H. The length from E to H is 1/2, because it's halfway between E and E prime. So once you know that, you can figure out the distance from A to H. And it's going to be √3/2 if you use Pythagorean theorem. So there you go, 1/2 √3/2. Those end up being those values there. This isn't a very good explanation, but hopefully if you were listening to the video, I mean, the solutions aren't that pretty, but if you were listening to the video, hopefully I talked through everything. I'll end this video here so I can get back to my basketball game.